Welcome to JVM. Run Java code on any machine. Here is what we will learn. Let's get started. Why do we need this concept? Different computers have different operating systems and hardware, making programs incompatible. How does Java run on any computer? Programs need oxygen monosulfide specific code. Hardware differences cause issues. Code must be rewritten for each system. The JVM acts as a universal translator, allowing Java code to run on any device. How is JVM used in the real world? Cross-platform apps. Run Java on any operating system. Android development. Power apps via Android runtime. Enterprise systems. Handle large-scale business applica. JVM powers all these applications. Let's see the problem it solves. So, what happens without JVM? Compiling separate executables for each OS. Look at how messy the code gets. Multiple builds needed. OS-specific binaries, no cross-platform portability. There has to be a better way. Here comes the solution, JVM. Look how clean the code is now. Write once, run anywhere. Automatic memory management, built-in security features. Compare the difference. And that is why we use JVM. Let's see how to implement JVM in code. Here is the implementation. Define class. Create Java class file. Main method. JVM entry point. Create string. Allocate memory. Print output. JVM executes instruction. Now let's see the output of this code. Quiz time. Test your understanding. What does JVM stand for in Java? Which one is correct? The correct answer is JVM is Java Virtual Machine, runs bytecode. What is the main function of the JVM? Which one is correct? The correct answer is JVM executes compiled Java bytecode. Which JVM component loads class files? Which one is correct? The correct answer is class loader loads .class files into memory. What does this code compile to? Which one is correct? The correct answer is Java compiler produces bytecode, not machine code. Here's a challenge for you. What's the output? Comment your answer below. If you found this helpful, please like and subscribe.